Section 10.2 is polygons and quadrilaterals. I can classify polygons and quadrilaterals. That's our learning target and what we're shooting for here today. A polygon is a closed plane figure whose sides are segments that intersect only at their endpoints. In a regular polygon, all the sides have the same length and angles have the same measure. The chart on page 516 shows some examples of polygons, regular polygons, and not polygons. So here in the first box, we see these are all polygons. They're all made of line segments, which means they're straight. They don't intersect anywhere other than the endpoints where they meet, and they're closed. So we draw the whole shape without any gaps. We can keep going. We can't tell where it starts and where it ends. And it's not curved or anything. Like I said, it has those straight sides. Regular polygons are the middle. Here we see a square, a pentagon, and a hexagon. All of these are regular polygons because they all have the same length of sides and their angles are all the same. In the last box, we have things that are not polygons. In the first one, they intersect at not the endpoints. So each triangle is a polygon, but the figure itself is not. The one on the right side there on the top has curved sides, so it's not just line segments. And on the bottom, it's not closed. It doesn't completely contain everything inside. There's a start and an end, and we can see those. So that is not a polygon. A polygon is convex if a segment joining any two interior points lies completely within the polygon. A polygon that is not convex is called concave. An example of this is also on page 516. So in convex, everything is inside. In concave, we can draw a segment that goes outside. I remember this because this is kind of like a cave in a mountain. It goes inside. Okay, it's a cut in a mountain, a cave in a mountain. So concave, okay, has that piece that goes outside of the shape. So concave, convex. In example 1, it wants us to tell whether each figure in example 1 is a polygon. If it is, classify it and tell whether it's convex or concave. If it's not, tell why. In A, it is not a polygon. It's closed. It doesn't intersect itself, but it has curved surfaces. So it's not line segments. Or it has curves. Okay. In B, this is a polygon. Now they want us to classify it and tell whether it's convex or concave. If we count up our sides here, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 sides we call an octagon, and all of our sides are the same length and all of our angles appear to be the same. So this is a regular octagon. And now whether it's concave or convex, there's no in parts. Everything is out if we connect any 2 points with a segment. They're always going to be inside. So this is convex. There's no caves like in a mountain where it juts in like that. So it's convex. Feel free to pause here and give these a try if you'd like. Tell whether each figure on the top of page 517 is a polygon. If it is a polygon, classify it and tell whether it's concave or convex. If not, explain why. Okay, number 1 is not a polygon. If we look here, 2 of its sides are not segments. Okay, so not line segments. You could say it's rounded. This is not a polygon. In 2, our 3 stipulations are all met here. They're all line segments. It's closed, meaning there's no open spots. We can't tell where it starts and where it stops. and doesn't intersect itself anywhere other than where it meets on the endpoint. So yes, this is a polygon. Now we need to classify it. Count up our sides. We have 1, 2, 3, 4, 5, which we call a pentagon, and all are the same length, and all the angles are the same. So we say it's a regular pentagon. 5 sides means pentagon. Now we want to know if it's concave or convex. If we connect any 2 line segments inside, we're never going to find any that go out of the shape. So this is convex. There's no juts in, like a cave in a mountain, so it's convex. And in 3 here. Our stipulations for it to be a polygon are met. They're all line segments. It's a closed shape. We can't tell where it starts and where it stops. And they never intersect each other than those endpoints. So yes, this is a polygon. It is not, however, a regular polygon. Some of our segments, like this one and this one, are different lengths. Our angles are different as well. So here's a small angle, here's a big angle. Acute versus obtuse. So this is not a regular polygon. We can count up its sides. 1, 2, 3, 4, 5, 6, 7. So we can just say a 7-sided polygon. Heptagon, it's not as common as other things, but you can if you'd like. Now, as far as concave or convex, and on the other ones too, if you don't remember that it's a pentagon, you can put 5-sided polygon. Not the end of the world there either. If we connect 2 endpoints here with a segment, it goes outside of our shape. This is going to be concave. It's like a cave in a mountain. It goes in here. So, concave. Some quadrilaterals have special names based on whether they have parallel or congruent sides. Remember, quadrilaterals have 4 sides, and whether or not they have right angles. The chart on page 517 describes some types of quadrilaterals. So a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Here it's the top and the bottom. A parallelogram is a quadrilateral with both pairs of opposite sides parallel, and they show us that with these 2 arrows. So they show us since this one has 2 and this one has 2, those are parallel. Since this only has 1 and this only has 1, those are parallel. A rhombus is a parallelogram with 4 congruent sides, meaning they're all the same length. All 4 sides are the same length. A rectangle is a parallelogram with 4 right angles, meaning it has both pairs of sides are parallel. So these 2 are parallel, and these 2, top and bottom, are parallel, but it has 4 right angles. And a square is a parallelogram with 4 right angles and 4 congruent sides. So a square is also a rectangle. A square is also a rhombus because of the 4 congruent sides. It's also a parallelogram. So a square kind of hits all of these on the nose. All 4 sides are the same by those little tick marks, and it has 4 right angles. Here's another little way of viewing those. Quadrilateral means 4 sides, therefore any 4-sided shape is a quadrilateral. The sides need to be straight, however, and are made from line segments. So if we look here, we can make any quadrilateral, so here's a quadrilateral, this one is not because it intersects. So if we want just parallelograms, see how if I move B, it has to keep them parallel, so it changes the others. In a square, these are all 90 degrees, so I can make it bigger, I can move it around, but I can't change the ratio of my sides here. They all have to be the same, and they're all 90 degrees. In a rectangle, I can make it longer or shorter, wider or thinner, but they all have to still be 90 degrees, and opposite sides have to be parallel. In a rhombus, all four sides are the same length, but my angles don't have to be 90 degrees. So opposite angles are still going to be the same, but my side lengths are the part that matters. And in a trapezoid, the only thing that matters here is that one set of lines is always parallel. So here it's AB and CD segments are parallel. Doesn't matter what happens with my other two. Okay, so properties of quadrilaterals here have four sides, four vertices, which are our corners, and all interior angles add up to 360 degrees. We talked about with triangles, they add up to 180. Here, they add up to 360. So to figure out if this is a quadrilateral, we could measure our angles and make sure they all add up to 360. Here they do. We have four sides, four corners. This is a quadrilateral. Common types of quadrilaterals are squares, rectangles, rhombus, trapezoids, and parallelograms. Quadrilaterals are sometimes called by other names. Quadrangles, meaning four angles, is similar in form to triangles. Tetragon is four, and polygon, so it's similar to pentagons, hexagons, heptagons, octagons, things like that. So a couple different ways that we can name them there. Rectangle is a four-sided shape. Every angle is a right angle, 90 degrees. Opposite sides are equal lengths and parallels. So we can see the two segments are parallel and the one segments are parallel. All angles are right angles. The rhombus, all sides have equal length, so all of my segments here have equal length. Opposite sides are parallel, and opposite angles are equal. Sometimes this is called a diamond as well. In a square, all sides are equal, all angles are right angles, and opposite sides are parallel. So a square also fits the definition of a rectangle in that all angles are right angles, and a rhombus, all sides are equal. It's also a parallelogram. We just haven't gotten there yet. So opposite sides are parallel and equal in length. Opposite angles are equal. So here my tops and bottoms are both parallel and equal in length. My lefts and right are both parallel and equal in length. Opposite angles are the same as well. Here they don't have to be right angles. So note here, squares, rectangles, and rhombuses are all parallelograms as well. And trapezoids. Trapezoid's kind of its own little thing here. One pair of opposite sides are parallel. So here it's the top and the bottom. Because the sides that aren't parallel are equal in length and the angles from the parallel lines are equal, this one is called an isosceles trapezoid. They don't always have to be that way. This one just happened to be. Okay, so in a trapezoid, only one set of parallel lines need to happen. It doesn't matter what happens with everything else. All four-sided shapes are considered quadrilaterals, even though not all quadrilaterals will fall into one of the previous categories. And some quadrilaterals can be included in multiple categories. So for example, here we have a square, which can also be a rectangle, parallelogram, or rhombus. So here, we're determine which ones are quadrilaterals. If they are, determine which category or categories they'll be placed. 1 is not, it has 5 sides. 4 is not even a polygon because of the curved sides. 6 has curved sides, so it's not a quadrilateral or a polygon. 7 has too many sides there, that's not a quadrilateral. And all the rest are. So 2 is a square, rectangle, parallelogram, rhombus. Here we have a rectangle or a parallelogram. Square, rhombus, rectangle, parallelogram, and trapezoid. And I will finish in another video.